Hey, thank you, and thanks for joining this session. So, as mentioned, I'm going to be covering off an overview on machine learning and artificial intelligence, hype or capability, and how that applies to cyber threats. So, for the agenda today, we're going to be covering off a number of different topics. We'll have a quick look at what's happening in 2021 with regards to the current threat landscape, across the globe, as well as in APAC and Japan, which is the region I'm working in. We'll have a look at a bit of an introduction to machine learning and AI, how it can be used to combat cyber threats, especially as it pertains to banking industry. We'll look at how we can leverage changing models and capability in machine learning to be able to augment some of the threats and challenges that we have. And then we'll have a look at some of the different capabilities that we have today to be able to help organizations, especially banking organizations, improve their cyber resilience and stop some of these threats that are happening. So let's get into it. So if we have a brief look at the threat landscape, anybody who works in cybersecurity or anybody who reads the news will be fully aware of some of these challenges. So, 2020 was a miserable year for ransomware. We believe over $20 billion lost globally to ransomware attack. We're seeing some additional activities coming through and additional threats, so a massive rise in phishing campaigns and smishing campaigns, as well as obviously activities as it pertains to mobile devices. So a big increase in fake apps, fake information happening on mobile devices. Also cryptojacking, which is a bit of a new one, but a massive increase, and that's basically stealing somebody else's CPU to be able to harvest or mine for digital currency or digital coin. As well as obviously continuing challenges around the insider threat, right? Just people doing silly things on networks and costing organizations many millions. The good thing though is that all of these are actually addressable by modern techniques leveraging machine learning and artificial intelligence. So the first one is ransomware. That's basically because you're using the wrong antivirus capability. So we're going to talk about that, how that's changed and the world's changed there. The other ones, these are new. We'll have a look at how do we address some of those threats, especially in banking. And then the insider threat one is now solvable. We can actually stop and we can predict when people are doing silly things, when they're pressing on buttons they shouldn't do, when they're accessing information they shouldn't have access to. We can detect all of that and we can stop it all in real time. So when we have a look at the kind of the future of endpoint protection, it's worthwhile maybe having a look at the past as well. So as I mentioned, the past is where we had traditional antivirus, which needed humans to create signatures of things that were going wrong on the internet. Somebody creates a virus or a piece of malware or ransomware that needs to be identified, and then a signature needs to be created for that specific strain of malware, and then tied and attached to the endpoint. Now that is no longer a workable solution, and hasn't been for over 5 years. We're currently in a stage where we're trying to find different ways of doing that. We talk about heuristics and sandboxing of endpoints, isolation, as well as endpoint detection and response. All of those technologies in the center are reactive. They need some specialist humans to be able to do threat hunting, to allow for execution on an endpoint, and then to go and have a look at what's happening on that endpoint. We fundamentally believe that all of those technologies, whilst very good, they are not the future of endpoint protection. We believe the future is based on machine learning and AI, which is able to stop and predict attacks from happening on the endpoint pre-execution. In other words, before something's even happened on that endpoint, that threat is quarantined and stopped. And I'm going to spend a bit of time and show you how we can do that. So as I mentioned, the challenges we face today, especially with regards to current and even in the past activities, is we see over industry anywhere between 350,000 and more new malware samples created every single day. Now, there is no way a human can even keep up with that type of trend, and that's why we need to use machine learning to be able to help us adapt to this threat. So artificial intelligence and machine learning fundamentally allow us to build a mathematical relationship between features of something, in this case probably a file on a computer, and to be able to understand disparate features in that file that's far beyond any human capability. We can do it in milliseconds, and we can decide whether something is good or bad instantaneously on an endpoint. And there's no human that's able to do that at at that sort of speed. It's more efficient, it's more powerful, it's more accurate than any human has ever been able to do to date to the problem that we have in cybersecurity and endpoint protection. So in order to kind of visualize how machine learning works, and machine learning in itself is probably a 3-hour topic for me to explain, but to kind of visualize it, I've got some examples on the board here. So here I'll introduce Skippy as my kangaroo. And what we can do with Skippy the kangaroo is we can start to look at different features or attributes of that kangaroo, right? So we can start to look at, and in this case, I'm looking at 8 different features of kangaroo. I'm looking at, are the ears hanging? Are the nostrils open? Is the tongue visible on this animal, etc. And then those numeric values that we then attach to that feature or that animal becomes what we call the dimensions of the sample. In this case, it becomes the kangaroo's feature vector. Machine learning is very, very powerful to be able to create feature vectors based on things. Right? Like very, very quickly be able to determine what a kangaroo looks like. Similar, if we go and map the same sort of process, the same 8 features against an emu and a koala using the same principles that I mentioned before, we can start to map the feature vectors of these 2 animals as well. Okay, and then if we go and put that into a feature dimension, we can look at those things as coordinates in a space. Now, this is a kind of a 4-dimensional space or 3-dimensional space where we started to map objects of similar traits together. And machine learning is very, very good at doing this, right? It can differentiate between features of a kangaroo compared to a koala very easily. So now we can start to correlate and visualize in a mathematical model where these things sit. So we can see, well, if you're in that green box, you're probably an emu. But if you're in the bottom one, you're probably going to be a dog based on your feature vectors, similar to koalas, cats, kangaroos, etc. Now, what we've done at BlackBerry is we've done exactly the same thing with portable executable files that run on computers. So looking at computers, we've done the same thing. So starting in 2014, 2015, building the first math models, training billions of lines of code as well as portable executables, both good software and bad software, and analyzing millions and millions of features of that software, we've been able to build mathematical models which can very quickly predict whether something is good or bad. So in this case, we can see we've got malware, WannaCry, Trojans, good software, as well as, for example, Microsoft software. And we can very quickly on the endpoint determine if this is something that's been written which is good, or it's something that is trying to execute which is inherently bad on the endpoint. Now, there's lots of research that goes into this stuff, a lot of intellectual property, there's patents around this. Our ability to be able to predict pre-execution is something that is quite unique in the AI and endpoint security world at this stage. So let's have a quick look at how this all works, and and how we get to be so good at doing what we do. So machine learning, as I mentioned, is pretty complex, right? But if we look at it from a simple level, we can apply to different products that we have. So we collect, I mentioned, and we analyze petabytes of good files and bad files. We extract the feature sets of all of those files, and then we take those feature sets or feature vectors, and then we do go through a process called transformation and vectorization, and then the math models train on themselves. They learn about this stuff. And the math model is then able to classify and cluster good stuff from bad stuff. Is this thing, is it a nasty piece of ransomware strain, or is it a, Outlook.exe, which is trying to execute on the endpoint? So with this powerful machine learning capability, we can start to predict threats even before they exist in the world. And this is something called, most people know this as a zero-day attack. So a zero-day is something that didn't exist yesterday, but is now attacking people today. So if we go and have a look at this, our math models are able to, and these are some examples of recent ransomware attacks that have happened around the world. Ryuk is a really bad one, Emotet as well, Wasted Locker as well. We are able to take a mathematical model which is able to predict nearly 3 years previously that this is actually ransomware or malware. It's actually a threat. So when this thing comes up, we've actually got math models that go back as far as 2015, which can very easily stop the latest ransomware variant that is happening today in 2021. And that's what we call the temporal advantage for AI and machine learning. It's very powerful. So if we have a look at how this, all of this capability starts to map into a banking and a financial services world, we talk about leveraging AI security that works smarter, not harder. We talk about helping banking organizations as well as your customers preparing for cyber threat, preventing that threat from happening. If it does happen, detecting it, and then obviously also responding to that threat. And how we do all of that is leveraging the Cylance AI capability across all of our solution stack under the cyber suite at BlackBerry. There's a lot of things in there: mobile protection, desktop protection, endpoint detection, response, threat hunting, behavioral and risk analytics, etc., etc. And all of those are underpinned by a full services offering by us. And we obviously work with a number of banks already globally who are already customers in this space. So very briefly, just looking at some of the different product sets that we have, our kind of hero product is BlackBerry Protect, which is that AI-based endpoint security solution. We call it the kind of edge AI, where we take the intelligence of the math model, we package that down onto the endpoint, and that math model is able to execute and determine good from bad instantaneously. It doesn't rely on cloud lookups. It doesn't rely on signatures. It doesn't rely on updates or daily scans, any of that sort of stuff. Everything is built into the edge, and it's using the math model at the time. Very, very powerful solution. It's got a lot of different features that are in there around being able to watch for files, being able to check and see what they're doing, what those files are trying to execute against. We do full disk scan analysis in the beginning. And then once that is implemented, then we can check for lots of different threats and activities that happen on endpoints, not just portable executables like what we call PUPs or potentially unwanted programs, but other malicious activities such as script control, memory exploitation, application control, etc. Having a little look at one which is doing the rounds or has been doing the rounds is this Ragnar Locker ransomware. So you can see here, we've got a number of hashes that are available now, predicted in the internet that we know about, and these are the victims that they hit. And we're now having a look at this predictive advantage in terms of how we are able to stop these hashes prior to execution. You can see in most cases we stop them, nearly 1,700 days before that even existed in the wild. And we have a look at the detections and evolution of this. This started in February, really, when Ragnar Locker came out. That's what we call a 0 day. And then we can have a look at the number of detections per day where this threat hit the globe, and we are able to stop it pre-execution on day 1 or day 0. And here are just some examples of how we're doing this. So we've had some recent examples of Colonial Pipeline hack from DarkSide. Emotet, as I mentioned, is a nasty one. There's a Loki bit is another one which is doing the rounds. And most of these, we can stop them based on our math model from 2015. So on the board on the left-hand side, you can see a math model which is running on an endpoint based in 2015. That endpoint has never been connected to the internet. It's been sitting dormant, has never been updated for over 6 years. And that version of the math model is able to detect and prevent all of these current 2021 threats. And it's not only us telling you this, it's also the hackers, right, or the industry. So here you can see on the left is the actual hacker note from DarkSide to Colonial Pipeline after their attack, recommending that they look at using a better antivirus product or endpoint protection product, such as BlackBerry Cylance. And we've also done very well in a recent breach response reward. So the SE Labs is a third-party testing where we got a AAA rating, stopping everything, 100% detection and prevention with 0 false positives, and all of the tests that they ran across some very, very tough advanced persistent threat groups like Fin7, Fin4, Fin10, Carbonac, and others. I mentioned previously that the challenges around the threat landscape with mobile. So there is a product for mobile threat defense where we stop, we look at putting, again, the same principle of machine learning math model onto an endpoint, stopping things like phishing attacks, social engineering, SMS attacks, malicious applications being installed on the devices. This is incredibly important in banking The reason for that is there are a lot of mobile fake banking apps that are out there in third-party app stores. So one of the things we do offer today, which is very powerful, especially for your own banking customers, is an injected SDK, which get added into your mobile banking app, and that is able to do mobile threat defense and threat and fraud remediation and detection straight on the device. So it's a great value add. It's basically just an SDK that is added in at software time when you're building your apps, and that's a great value add for any of your banking customers. And we're working with a number of global banks as well as local banks here in my region in APAC to be able to help them implement this for better customer threat prevention on mobile devices. And then very briefly, we've got other capabilities as it pertains to endpoint detection response, because BlackBerry Protect will stop nearly 100%, but nothing ever stops everything 100%. So if stuff does get through and does get executed on the endpoint, potentially it could be something like a weaponized document, or it could be a malicious script that's running, or somebody's been able to get in with privileged credentials onto a domain controller, and they're starting to do additional activities, which is anomalous. Then our product for endpoint detection and response is what's called BlackBerry Optics. And it's basically this threat hunting, on-demand root cause analysis capability and remediation, automation, everything using AI to be able to stop that threat as it happens. And here we can see an example of a threat activity in your ongoing. So this is using BlackBerry Optics. We can see on the top left, somebody's opened an attachment, which is in Outlook, which is usually okay. But then that attachment, opened a macro. And then there's some network connectors to Bitcoiners that would definitely raise some flag, right? So there's something going on here. There's some privileged escalation of a Microsoft protocol, which would definitely be flagging anomalies, and we'd want to be stopping that. So that's what BlackBerry Optics is for endpoint detection and response does. I mentioned previously the insider threat problem. So now we've got capabilities, and a number of vendors out there do around user entity behavioral analytics. This is basically the way that you can learn, I am who I am on the device that I use. And if somebody else were to compromise my device or get access to my device, then I can very easily and predictably understand that that is no longer me, and we can then make informed decisions. So an example of this is local math models that run on it. This is an example of 4 different users who were asked to just draw a circle on a mouse with a line through it. And every single user is unique. The way you use your mouse, you use your keyboard, when you log in, your time, your network, and we can build a math model to really understand you are who you are, and we can start to detect for anomalies. We provide for mitigation activities around things like password or two-factor authentication, and it's basically everything around the zero trust or user trust assessment. And with all math models, similar to what we do with endpoint protection, we look at different scoring thresholds. So if your scoring threshold is 100, you're happy days, or if you go keep on working as you are. But if it drops below a certain threshold, we might just prompt you for a username and password. Or if it drops below another threshold, maybe we'll ask you to do a two-factor authentication on that specific resource. And that's it. So hopefully that's giving you some ideas. Just to recap, we've been using advanced artificial intelligence and complex mathematical learning models for many years now, and it's something that we believe in as the future of endpoint security, as well as cyber threat mitigation and remediation, because basically the power of machines and not humans are the way that we're going to be able to determine good from bad, whether that's good from a file perspective or from a mobile perspective or from a person perspective. The principles are exactly the same. So I hope you've been able to get a good understanding of what we do and what we can provide in the industry, as well as to banking organizations. And I hope you have an enjoyable rest of your summit. So thank you very much.
Thank you, Mr. Jonathan Jackson, Director of Sales Engineering, APJ BlackBerry, for giving us a very wonderful and insightful technology presentation on using artificial intelligence to prevent cyber attacks. We will now have a short break of 5 minutes where you can network and visit the expo. And we'll return in exactly 5 minutes for the second panel discussion on AI blockchain cloud a reality check. Thank you.